So today we are going to do day 2 law of sines and law of cosines. Let me go ahead and share my ladybug. You guys hold open, connect it. So here we go. Again, remember, if you guys have any questions, you can unmute yourself. You can put it in the chat, whatever works best for you. So day 2, so these are going to be problems from your assignment. We kind of saw something like this yesterday when we went over the instruction portion. And so this idea that we could take this triangle and break it up into 2 separate triangles where they have this common height, the altitude, so it's the height of the triangle. And so they want us to use this diagram to derive the law of cosines. So where did the law of cosines come from? And yesterday when we talked about in the notes, we were actually deriving the law of sines. We used it to help us find the law of sines. Today we're going to focus on the law of cosines. So it's asked us just to fill in the missing pieces. So I look here and I go, okay, well, here's what we started with. So we started off with this, and then the next statement is, what is h squared? Well, all we did was subtract x squared from both sides. So my h squared then would be a squared minus my x squared. That's all they're looking for. So don't overcomplicate this. Sometimes we really want to make things harder than what it really is. My next step then says that c squared is equal to h squared plus b minus x squared. Well, there's this piece right here. Where did this b minus x come from? Well, if this whole thing is b and this piece here is x, then this would be our entire piece minus this little piece that we have of x. So that's where that b minus x came from. So b minus x is talking about this piece right here. So if that's the case, then what they want us to do for this, when we say b minus x, remember that it's quantity squared, it's b minus x times b minus x. We don't just distribute the square to each piece. That's not correct. It's saying that we're taking that quantity and we're squaring it. So I would need to distribute everything through. And when I do that, I would get b squared minus bx minus a bx and plus an x squared. And these two can be combined. So what they're looking for this piece is it distributed out. So b squared minus there's 2 bx's plus my h squared. So you can see how this is now this piece. They're equivalent. And then I go, okay, well, what happened from 4 to 5? Well, they added this piece in right here. But this is all the same as this up here. So what happened there? Well, we already said that h squared is equal to this. That's what we said right here. So that's where that piece came from. So all they did was substitute that in. Okay, well, then what's my next step saying? Well, I look here and I go, okay, can I clean any of this up? And I notice that I have a negative x squared and a positive x squared. So those would cancel each other out. And when I cancel them out, I'm left with my a squared plus my b squared, and then I have this minus 2bx. So that's what's missing here is this minus 2bx. I know that this value of x is equal to a cosine of c. It told me that, but I can also use my values of SOHCAHTOA to solve for that. It's just the right triangle, so I can use the idea of my cosine, but they already filled that in. So if that's what this x is equal to, then all I'm going to do is plug this value in right there. That was just my x value, and I just plugged it in. And there's my law of cosines equations. This right there is your law of cosine equation. Done. So when you're doing these, you're basically just kind of working through the algebraic pieces of this, and they give you the triangles so you could correspond where they come in from. This might have been the hardest piece of like, well, where did they get this value of x? Again, maybe I'll quickly show you. Remember that this value of x, it's using cosine. We're looking for cosine. Remember, cosine is going to be your adjacent over your hypotenuse. So my adjacent side here was my x. My hypotenuse is going to be this a value. So when we talk about cosine of my angle C is equal to my adjacent side, which is x, over my hypotenuse, which is a. And then if I solve for that x, it tells me x is a cosine of my c there. So that's where this piece came from. They already did the work for you, but just so you guys know where it came from, because it's with a right triangle right here, we can use our SOHCAHTOA for it. All right, so same kind of idea here as well. So they're kind of putting everything again together for you guys of where are this law of sine and cosines coming from and this idea of these triangles. So it says, which of the following statements are true? Check all the boxes that apply. So let's go through and read them. Triangle ABC is a right triangle. So I look here and I go, my ABC, is this a right triangle? No. Inside it, there are some right triangles, but triangle ABC is not a right triangle. So this was a no. So read the next one. Segment H divides triangle ABC into two congruent triangles. Are these two triangles going to be congruent? Well, visually looking, they don't look congruent, and there's nothing that's marked saying that this side is equal to this side. And how do you know what something marked would look like? If you guys remember when we talked about triangles before being congruent, probably in another class, you can go ahead and you can mark pieces congruent with little tick marks like this, and if these two sides were congruent. So there's no markings. You can't assume that they're congruent. There's no values given. So no, these are not congruent triangles. Segment H divides triangle ABC. So it takes our triangle ABC and it divides it into two right triangles. So this segment divides into two right triangles. That's absolutely true. Some of you guys wonder though, but it only has a box here. Well, if this is going to be 90, then this has to be 90 because they're supplementary. They add up to 180. So it does divide it into two right triangles. A squared is equal to B squared plus C squared. This is true for right triangles, right? This is our Pythagorean theorem. I look here, A squared is equal to B squared plus C squared. That can't be true because we're not working with a right triangle there. This triangle ABC is not a right triangle, so you can't use the Pythagorean theorem for the sides of that triangle. So this is also a no. All right. C squared is equal to H squared, and then we have this yucky piece right here. But if you guys remember from the problem we just did above, this is this piece right here, which was just the factored form of this, right? So all of that is the same thing as saying H squared plus B minus X squared. You guys recall seeing that? Why did I write it like that? Here's why, is because it's saying that C squared, this is my C, this is my B minus my H, and this, or sorry, my X, and this is my H, and I have a right triangle. And it's true that if I take my C and I square it, it is equal to the two legs. So my B minus X quantity squared and my H squared. This is true. It was tricky because this was already in factored form, so it might have thrown you guys off, but hopefully now that you guys have seen this a couple of times, it might trigger you to think, oh yeah, that could be factored out. And my last one, if you know sides A, B, and C, you can find all the angles in triangle ABC. So some of you guys are like, well, no, because if I don't know any of the angles, how can I find some? But remember, if I know my side, my side, and my side, even though it's not a right triangle, so remember, not a right triangle, but I know all three sides, then I can find any angle. This SSS is when we would use our law of cosines. So we can find all the sides of that triangle. So again, this is a lot of really kind of getting to understand what do you need to know or how do you go about it. On the back side. Which of the following statements is true? Check all the boxes that apply. So again, we're taking things piece by piece. So I need to check all that apply. Okay, first one says that sine of A, so here's my A, so I'm using my sine, so I like here my so, ka, toa. So this is telling me that sine of A has to equal, so sine of A is going to equal my opposite over my hypotenuse. This would be my hypotenuse. This is my opposite. Kind of confusing because I'm using H for my hypotenuse, but this is my variable H. So my opposite side is that value of H. My hypotenuse is this value of C. Hold on, I got someone that added in. Okay, make sure they get in. Okay. So this is my value of C. And so I know that sine of A is H over C, and that's what this first one says. Perfect, this is true. Okay, so then my next one, well, now things are getting a little bit trickier. That B sine of A is equal to A sine of, B. I don't know, is that true? So here's what I want to do. I want to break this apart. So I know that my sine of A is H over C, right? So then, let's see, which ones do we want to use? Actually, let me go with this. I'm going to skip to this piece right here, and then I'll go back because I'll show you what happens. So if I have a triangle, remember, if I have a triangle, I can use my law of sines. This is what my law of sines is, right? Is that sum A over the corresponding angle sine of A is equal to B all over sine of B is equal to some C all over sine of C. So for A, B, C, all of these are going to be equal to each other. This is my law of sines. This is the definition of it. Law of sines. These ratios are true as long as it's over the corresponding angle and side. Those are corresponding. So when I look at this first one, I know that I can do these two together. That's a true statement. I could do these two together equal to each other. I could do these two equal to each other. I could do any combination of those law of sines, and it's all going to be true because they're all equal to each other. So I know right away that this is going to be true, and I know this is going to be true. What I don't have exactly yet is this last one right here that I skipped over. That's because this piece, it's talking about these two. Well, this isn't written as a fraction. So all I need to do is if I cross multiply, and I would get B sine of A is equal to my A sine of B. And I look up here, and that's exactly what this is. So this is also true. Means they were all true. And that really trips you guys because you guys think something's got to be wrong. I made a mistake. No, nope, not necessarily. They're all true for this. And then we have a question. So let's go ahead and let's answer this. So you'll have some that are actually just thinking about the equations that are using these triangles in your instruction today. And then you all have some that are actually solving them. So if I'm solving this, before I even read the question, I'm just going to go ahead and I'm going to label this. This is a variable D, so across from it, I'm going to call this D. I'm just going to call this triangle B, C, D. I'm making up the other variables. So this would be my side B, this would be my side C. And the reason why I do that is because I know I'm going to be solving something in this triangle. I'm probably looking for this D. That's what it's going to say right here. So I'm going to fill in everything that I know. So I know that this angle D is 65 degrees. I know that my side B is 130 meters. My side C is 90 meters. My side D, that looks like what we're going to be looking for. So it says a surveyor, oh, sorry, you guys can't see it all. A surveyor measures the distance to two landmarks. So measures the distance to two landmarks. My chat's in the way, hold on. Move, it's not letting me move it. Okay. So measures the distance to two landmarks as shown in the diagram. So what is the distance D between the two landmarks? So here's a landmark and here's a landmark. They want to know how far away are the two landmarks from each other. So we are looking for this D value. This is what we want to find. Okay, well, why did I set up my information like this? That's because when I look at this, I'm going to use the law of sines if I have what? Yeah, a full set. Do I have a full set here? No. Remember, full set has the angle and corresponding side. I don't have that, which means I'm going to have to use my law of cosine. So if I don't have a full set, I have to use my law of cosine. And I want side D. So what this tells me is that D squared is equal to B squared plus C squared minus 2BC cosine of angle D. And I plug in the information I was given. I was given my side B, my side C, and my angle D. So I have everything I need. So it's 130 squared plus 90 squared minus 2 times 130 times 90 cosine of 65 degrees. I go to my wonderful calculator and I plug this in. So 130 squared plus 90 squared is equal to 25,000 minus, I'm going to do 2 times 130 times 90 times my cosine of 65, and I get 9,889.3. I'm going to go ahead and subtract 25,000 minus my answer there, and I get a value of, so remember, I do all of this as one value, and I do my first set, these two together. So that's where these two numbers came from. You cannot subtract this number, this value, the coefficient of your cosine with this, and that's a common mistake. So be careful there. All right, so I go ahead then, and I have that D squared is equal to 15,110.7. I want to take the square root of both sides, and this tells me that D is approximately, so it's going to be my answer. I just put it to the 0.5. It's the same thing as the square root. 122.9, and my units were meters. They actually, it's a drop-down menu, so they actually have you do the answer of 123. They ran it to the nearest whole number. So you don't have to decide on that one when it's a drop-down. It's only going to give you either something with a decimal or the whole number, whatever it is. That's all I have for you guys today. Again, I cannot stress to you guys enough. Don't worry if you show behind in Edgenuity. Don't freak out. This is for your benefit. Just stay on track with what I put on the weekly calendars. I send them out every Friday through Remind, or of course you can access it through your Google Classroom. So stick with my calendars that I provide. You don't need to do more. It's okay if you're behind in Google Classroom. It is totally okay to be behind, or not Google Classroom, in Edgenuity. If you're behind in Edgenuity from what it says, but you're following what I tell you, that's totally okay. So if you guys have any questions before I let you guys go today. Nothing.